Good evening, students.
Good evening, ma'am.
Good evening, students. Can you hear me and see me?
Yes, ma'am.
Okay. Can you hear? Am I audible to all of you now?
Yes, ma'am.
Okay. Have you revised the concepts which we did in the last class? Anybody having any issues in that? Just wait for a minute. I'm just connecting with the team for the screen share issue. Till I get the access for the screen share, can you tell me how many groups are there in the modern periodic table?
Groups.
I didn't get you a bit slightly more louder.
18 groups.
Okay, good. So till now we have learned about the earlier classification. We were talking about the modern periodic table. We have done one type of numbering for the groups, and we will be beginning with the other way of numbering the groups. Then we move to periods. And then we will understand the various properties or the characteristic trends in the modern periodic table and how they move, how they change when we move from left to right or right to left or top to bottom or bottom to top in the periodic table, right? So is my screen visible to all of you now?
Yes, ma'am.
Okay. So in the last class, as I told you in the beginning, we understood how to number the groups of 1 to 18, right? Now here is
Yes,
the
ma'am.
another way of numbering the groups. As you can see, group 1A is named as group 1A. Are you able to follow it?
Yes, ma'am.
Group 2 is numbered as 2A. Then group 3 is named as 3B, 4B. Group 7, till group 7, they are numbered as group 7B, right? And then we have group 8 having 3 rows of iron, cobalt, and nickel. Then we have group 1b starting with copper, 2b beginning with zinc. Then we have 3a to 7a, and finally the 0 group. Now, can anybody enlighten me or tell me why a certain group is numbered as A and why a certain group is numbered as B? And a hint to you, that answer lies in the electronic configuration of the elements of this group. Okay, let us recall what was the electronic configuration of block S elements. Anybody having, or rather remember that?
Mom, it's this group.
I couldn't hear you. Please be louder and repeat again. I'm so sorry for that. For S block, it was NS1 to 2. For P block, it was NS2, NP 1 to 6. For D block, it was N-1, D1 to 10, DN-1, NS1 to 2, right? Now, the electronic configuration suggests that S block and P block elements have only one shell incomplete. That is, their valence shell is incomplete. Whereas, in case of D block elements, they have 2 shells incomplete. Remember, or rather, I'll say recall, in the last class when we talked about it, right? We understood that the D electron enters into penultimate D orbital, right? So why some group elements are, some groups are named as suffix having A, and while others have suffix B? Please notice all the groups which are having A as their suffix, 1A, 2A, 3A, 2, 7A, and 0. All of them have only one shell, that is valence shell, which is incomplete. But from 3B to 7B, 8, 1B, and 2B, all of them have 2 shells, that is valence shell and a penultimate shell incomplete. Is this point clear to all of you?
Yes, ma'am. Yes, ma'am.
Okay, please note it down. It can be a question of reasoning or maybe a multiple choice question anywhere. A question comes to students' mind: why iron, cobalt, and nickel, all of them are named as or numbered as group 8? See, no logic is there into it, but they are said as group 8, so they are said as, like we say, the sun rises in the east. So it's as simple as that, that they are said to be group 8 elements, that's all, right? One of the reasons which I can think, again, I'm saying it's not written anywhere, which I can think is they resemble each other a lot in their properties. Iron, cobalt, nickel are very, very close to each other in their chemical properties. Probably that is the reason they are kept in the same group umbrella, that is group 8, right? So that is one information which was pending in the numbering of group. That day I thought I will teach both of them simultaneously, and I tried to, but I thought there was a lot of commotion in the class, so I retained it or kept it for today. Now, I remember that I gave you one atomic number and asked you to write the electronic configuration, and that was for F block. Anybody remembers that, or have you written that? It seems all of you have forgotten that homework.
The question.
I think I gave you 60 or 61. I need to go back in the slides and find it out what we were doing this. Yeah, here it is. Atomic number 62. That day we wrote it for 11, 17, 23 and 62. I remember I told you to write the electronic configuration for element having 62, which is of course a F block element, right? Are you able to recall this now? Ritika, can you recall it now?
Yes, ma'am, I do.
Okay, but all of you forgot to write it. Please quickly write the electronic configuration of 62. So that we are done with the blocks and the periods. There is again something to teach you in that.
Done now.
Done. Tell me what is this? What 62 is coming it as?
Now I got 1s2, 2s2, 2p6.
Hold for a second. Let me write also. Yeah. Please carry on. 62 is
1s2, 2s2.
Yeah.
2p6.
Yeah.
3s2. 3p6, 4s2. 3b10. 4p6. 4b10. 4f14. 5s2.
4d10. Then what do you say?
4f14. 5s2.
Have you followed the above into it? Even I don't remember, but I'm pretty sure 4p, 4d and 4f cannot be consecutive. Please check it and tell me again. So have you referred to your chapter 2, structure of atom? Towards the end of the chapter, they have given you the entire set of the 118 elements with their correct electronic configuration. This is the one way they have referred it, right? As if I ask all of you to write, it is going to take a lot of time. One sincere request to all of you that please make practice. Please do a lot of practice about it, right? The purpose of you to make the write this element configuration is to tell you how many shells are incomplete in it. If you look at this, you will understand that it has got 3 shells incomplete. Do you agree with me or not?
Yes, ma'am.
So what is its general electron? So I am not going to tell you now. In the next class, we will take on the same element again. And this time, I will give you 60, I will ask you another question in this because we need to cover an entire syllabus. And another thing is, one thing is that I have to cover the syllabus at the same time, students have to make the practice of it, right? You must remember, have you heard what is Euler diagram? Can anybody tell me what is Euler's diagram? As you said that you have completed that chapter. Any idea? What is Euler's diagram? Please note down the Aufbau. 1s2, 2s2, the entire thing you draw. 2s2, 2p6, 3s2, 3p6. Or rather, you don't put the numbers, you can just draw that one, 3p, 3d, then 4s, 4p, 4d, and then 4f. Can anybody tell me why don't we have 3f? Or why don't we have 2p6? Or rather, we don't have 2d. Is it clear? Is the question clear to all of you? Dear students, please respond.
It's because the holding capacity of each shell is 2L square. So it cannot hold more than that.
Yeah, very correct. Everyone works on the principle of conservation. If I have only 3 floors in my house, why should I be making the stairs for the 4th floor? We will not make it. Since according to Borbury's law, the 3rd orbit can have maximum of 18 electrons. So we should need only 3s, 3p, and 3d. 4 onwards, we have 4s, 4p, 4d, and 4f. For 5th, 6th, and 7th, we again put sp, df. Although the orbital named as G and H are also discovered, but they are beyond the syllabus for class 12 and the competitive exams. Please note, if somebody might has not told you, I'm teaching you this one, that the entire thing, that Euler diagram, Aufbau, the way you draw it is known as, then you put up the arrows like this, right? This one is called as Euler diagram. And similarly, what is Aufbau? Any idea? Although it is off topic, but it is still an important question. What is Aufbau? Okay, again, please write down. It is not a name of scientist. Usually, most of the time in science, we hear the rules and laws in the name of the scientist itself. But Aufbau is a German word. It is one of the multiple choice question asked around 2 years ago in NEET entrance exam, that which of the following is not named after a scientist? Aufbau is a German word which means building up. It's not a name of a scientist. There are very rare instances are there. Is it clear? And I'm putting this slide separately, and we'll be discussing the F block configuration in the next class. That is, which will be on Monday, right? And you will be writing it for 62, and let's say you'll be writing it for 104. 2 elements. Please note down. And then I'm moving to the next concept which we have to learn. Now, the another name for groups is families. The group 1 to 18 are also known as families. Please remember, they may say boron family, carbon family. So they are referred as families also. They are numbered as 1 to 18 in Arabic numerals, which I have done, or rather we have understood. And all the elements of the same group have similar. Please remember, we are using the word similar, not identical, right? Group 1 elements, lithium, sodium, potassium, will have similar physical and chemical properties, or they will show the gradation, right? This is important. Never use the word identical here. That was the purpose of putting it here. Now, here are certain information for various groups. Have you heard that group 1? What is an alkali? Can anybody tell me?
Mom, they lose 1 electron to gain stability.
Lose 1 electron. Okay. In my opinion, you must have done it in class 10th. What is a base? What is an alkali?
Valence shell has 1 electron.
How come? Okay. And what about the valence shell having 2 electrons? Then what I will call them as?
Alkaline earth metals.
Earth metal.
No, I am not interested in knowing why. My concern is I want to understand why group 1 is also known as alkali metals, or some people call it as alkali metals. So my question is, what is the meaning of alkali? Right? Why you are given, you have, or the scientists have given it the name as alkali? I believe every one of you has a particular official name, as I can see, Ananya, Ritika, Shraddha, etc. Right? So your parents must have given you such a beautiful names based on a certain facts. Suppose I can tell for my name that I am named as Shikha. This name is given to me by my father. He wanted a daughter who is on the top of the world. So in Hindi, the word Shikha means top of the mountain. He gave me this name. Similarly, if I have named, or the scientists have named a group 1 as alkali metals, what is the meaning of alkali, or why are they called as alkali metals? The answer comes from the fact which is taught to you in class 10. What is a base and what is an alkali? I was not asking to define group 1. I believe the students have taken it in that spirit that they have to define group 1. No, I want to just tell me what is a base and what is an alkali. I believe my question is clearer now to all of you. Now, can any one of you define alkali for me?
Are they hydroxides?
Mom, they are bases, like when they are like mixed with water, we have base, like that properties of base.
Yeah, it is written on the screen itself also. We have acid, we have base, we have alkali. I will quickly explain those to you. We say proton donors are acids, or they produce H plus ions when dissolved in water. For class 10th student. Class 11, we will study the chapter equilibrium. We may add few more things to that. But for as of now, we will say acids are proton donors. Bases, as I'm sorry, I couldn't see. Someone of you said that they produce OH minus ions. Correct. But what is an alkali? Water soluble base is called alkali. I believe it was one of the most important concepts in the chapter of acid bases and salts in class 10th. Water soluble base is called alkali. Please remember it forever now. So group 1 elements are also known as alkali metals. Why? Because they form water soluble bases, which is written at point number 3, right? So when they react with water, they form water soluble bases. Now, someone who said that they produce only oxide, bases can be, hydroxide. Bases can be oxides as well as hydroxide. For example, magnesium oxide is also a base. I believe the difference between the base and alkali is clear to all of you. Else
Yes,
we will have to, okay,
Yeah.
thank you. Else we will have to spend some time on it again when we talk about, when we move to the chapter equilibrium, right? Moving to the group 2. Group 2 elements are known as alkaline earth metals. Now, why are they called as alkaline earth metals? The answer is simple. They form water-soluble bases and which are found in earth crust. If you have noticed that whenever, although these days we talk about Asian paints and tractor paint and blah, 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 various colors can be seen in our walls. All of them are synthetic. Nothing is man-made there. But in the ancient times, calcium oxide was used for, or calcium oxide, calcium carbonate, all of them were used for whitewashing, right? So what are they? Calcium oxide, calcium carbonate, they are found in the form of rocks. So therefore, their oxides, carbonates, and all those compounds are found in earth, basically the oxides, right? Calcium oxide, magnesium oxide, they are found in earth and they are basic in nature. And more importantly, they are alkaline. They are soluble in water. So therefore, we gave them the name alkaline earth metal, right? And that rest of the things we know, that they have 2 electrons, one shell is incomplete, right? Moving on to the another name. We have done this. What is a group 1 or alkali metal? Group 2, this. Group 16. For the sake of convenience, I have written this. They are group 16. They are called as chalcogens. Group 16, can somebody name all the elements? Oxygen, beginning with oxygen, then we have oxygen, sulfur, selenium, tellurium, and polonium. Polonium is radioactive. I think I have told you that radioactive elements are, or the transuranic elements are found in very small quantities and their lifespan is too small. Usually, if I'm saying the properties or any property, let's say atomic size, is increasing from oxygen to tellurium, that is also correct. And if I'm saying it is increasing from oxygen to polonium, that is also correct. Because the last, sometimes we make, it's not mandatory to consider the last element always, right? Most of the things in the earth crust are formed in the form of oxide or sulfide. Unfortunately, there was a chapter in, or I think you must have read about metallurgy in class 10, isn't it? Where you talked about the oxides and sulfide and calcination, roasting. Do you recall those terminologies, Ritika?
Yes, ma'am. We studied it in last year, acid bases and salts.
Acid bases of salts or metal non-metals?
No,
Metallurgy?
metals and non-metals. Metals and non-metals. I said.
Yeah. Metals and non-metal, that doesn't matter which chapter. We talked about metallurgy, the process of extracting metal from their ores, right? There, if you noticed, most of them were found in the form of sulfide or oxide. So basically, most of the elements in the earth crust are formed in the form of oxide or sulfide. Therefore, group 16 in general is known as chalcogen. Some of the books and some of the authors believe they should be considered only tellurium. They should not consider polonium for this. So it depends on what is asked and what can be answered, right? If you write oxygen, group 16 is known as chalcogens, correct? But most of them are formed in the form of oxides and sulfides, right? So there is a slight difference. If you look at the what is group 17, I have written they are salt forming. And for chalcogens, we have said ore forming, right? Ore forming.
Yes,
There is
ma'am.
this, I think the spelling is incorrect. It has to be ore forming, not farming. So what, can somebody tell me what is this? What is the difference between ore and salt, if you can understand that? See, salt families, do you remember? Again, it's a topic from your acid basis salts class 10. You might have heard about sodium family. What it will have? It will have, let's say, sodium chloride, sodium bromide, sodium sulfide, etc. If I say chloride family, then it will be sodium chloride, potassium chloride, ammonium chloride, etc. So they basically form salt. Group 17 elements include fluorine, chlorine, bromine, iodine, and acetylene. So most of the elements are found in nature in form of their salts as chlorides. Seawater is a rich source of sodium chloride. You must be knowing about it. What is salt farming? Again, a topic of class 10, right? Ore is something when we talk about the manufacturing level, we talk about something is present in a large quantities, right? Then we say it is a ore. Ore and mineral was something which was taught to you in the class 10th. We are not going to into details of it. If required, we'll be talking about them in class 12. So ore and salt are just a minute difference. Ore is something which is found bulk in nature, and salt is something which is probably slightly in a lesser quantity. Is it clear till group 17?
Yes, ma'am.
Okay, talking about group 18 elements. Group 18 elements are known as noble gases, as well as inert gases or inert elements. Now the question is why, which is better and why? Again, it's a reasoning question. In this chapter, you will find many reasoning questions. In the earlier chapter we did a lot of numerical based question. Here we'll be doing a lot of reasoning based question. Noble means special. Like we can say God. They can we haven't seen them, but we believe it is something other than us and beyond us. Inert. Inert means unreactive. So which is a better name for group 18? That is a question frequently asked in the exam. I will say the correct answer is that they are named as noble gases or noble elements. Why noble? Because they are elements, and such an element which are unreactive. That makes them noble or special. Rest of the elements react. Some of them react to a larger extent, whereas others react to a smaller extent, right? So, and why I'm discarding inert? Because the group 18 elements include neon, argon, krypton, xenon, etc. And of late, some of the compounds of xenon are made, specifically the xenon fluoride and xenon oxide, XeOF2, Xc2O3. Now, since the compounds of xenon are made sometimes in 1960s or 60s, they were made. So now that means they can react under a very, very special and drastic. Drastic means difficult condition. So it's better to call them noble metals or noble elements or noble gases, because all of them are gases at the end of the day. And when I'm teaching you, another question comes to my mind. Why only fluorides and oxides? And that too of xenon. Why only xenon? That we will answer when we talk about the properties. But why oxide or fluoride? Because oxygen and fluorine are highly reactive. You will find every element reacting with them, maybe metal or maybe a non-metal, right? So therefore, they form oxide or fluorides, right? So both, again, I'm repeating myself, noble group 18 elements, zero group elements, another name, zero group. Why zero group? Their valency is zero. Valency is zero means helium has 2 electrons having completely filled outermost shell, and rest of them, neon, argon, krypton, xenon, all of them have 8 electrons in their valence shell. So the shell is complete or the shell is shut, right? So they do not react further. That means they have zero valency, and hence they are known as, it is known as zero group also. So we have 4 names to group 18. The best one are group 18 and inert, or rather noble gases. Clear to all of you?
Yes, ma'am.
Okay. Now coming to the next thing. We will talk about this. What are normal elements? What are transition elements? And what are inner transition elements? Any idea? Can somebody tell me what are the normal elements?
S block elements.
I didn't hear you. Who was that?
Ria ma'am, I think
Yeah.
normal elements are S block elements. I'm not sure. It's just a guess.
Okay. I just heard S block elements. That's a guess. I don't know what else Ria said to me. If I have missed anything, then please repeat, Ria. Normal elements, I will say.
That's what I
S.
said, ma'am.
Okay. I will say S and P block elements are collectively called as normal elements. Why normal elements? Because, as I told you, they have only valence shell incomplete, right? If you look at their electronic configuration, you can predict their valency, right? So if you have sodium, I'm just writing orbit configuration 281. You can understand its valency is going to be +1. If I write chlorine, it will be 287. I can say it will be -1. Oxygen 26, it will be -2, like that. So they are called as normal elements, that their valence shell, their configuration reflects their valency or their chemical behavior, how they are going to react with other elements. Now, talking about transition elements, any idea? Or somebody can tell me what is the meaning of word transition in English? Or what do you understand by this?
It's like changing, like change from the original properties.
If the properties will change, element will change. I will tell you the meaning of transition here. See, I'm taking an example. Let's say this is your home and this is your school. When you start from here, let's say at 7 o'clock, and you reach your school at, let's say, 7:45. Whatever time is in between, we say for this 45 minutes, you are in transit. You are neither at home nor you are at school. You are in transit. You are in between the two places. You are in between your home and school. Is it making sense? What is the meaning of transit and transition? Transition, I understand. Now I got it. With the Instagram reels and everything, you people might be thinking that one thing is changing into another. No, that was not my ask at this moment. Transit to me means that we are in moving state. We are not at one place, right? We are in between two things. If you look at the periodic table, what do you see? What is this is our entire D block. This is our P block, and this is our S block. So D block is placed between highly metallic S block elements and highly non-metallic P block element. Therefore, it is called as transition elements or transition metals. All the elements placed in D block are metals. Every element is a metal. So transition metal and transition elements can be used as or understood as a synonym, right? It is a transition how on moving from left to right, the metals are changing their behavior or the elements are changing their behavior from metallic to non-metallic properties, right? You may not be very clear about what is a metallic property, what is a non-metallic property, but still, again, I say focus on the element sodium and focus on the element chlorine, right? It will be easier for you always to find the periodic table. Bit interesting. Whenever you are lost somewhere, think of sodium and chlorine. You will notice one is on extreme left hand, another is on extreme right hand side, right? So that's how it works. It's a metal, it's a non-metal, and they are changing, the properties are changing. Is it clear? That why the D block is known as transition elements?
Yes, ma'am.
Yes.
Okay, moving to the F block. F block is commonly known as inner transition. Why? If you notice, this is cerium, which is a F block element. And before it, what is there? We have 57, which is D block lanthanum. Where it ends, at this after lutetium, what do we have? We have hafnium, atomic number 72. So what is they? They are in between transition elements. One end is transition element, another end is also transition. So whatever is in between them is called as inner transition elements or inner transition metals. Similarly, you can look for thorium also. Atomic number 89, actinium, and atomic number 112. Although at that time it was not complete, you will again find them in between two D block elements. So therefore it is called as, both of them are called as inner transition elements, right? That's how another way of representing them. It's just a block diagram to tell you that what are the inner transition elements. Now talking about periods, we will do it quickly. Periods are always from left to right. We right to left is also a direction. But normally, whenever we talk about group, we talk about the trend from top to bottom. And in a period, we talk about left to right. If I have to give you a difficult question, I may be asking you about right to left. So I think we have discussed that periods are numbered from, as you can see, the periods are numbered from 1 to 7. All the periods are now complete. This period number 7 was not complete 3-4 years ago when the new 4 elements were not discovered. All of them are filled now, right? So we say all the 7 periods of the modern periodic table are filled. First period has got 2, second has got 8, third has got 8, then consecutive have got 18, and then 32 elements are present in them. If you spend with some time with your periodic table, you will come to know about, I say, the geographical features of periodic table. What is a group? How many groups? What are they named? What are the members? Right? Then, yeah. Anybody asking any question?
No, ma'am.
Okay. Another name for lanthanides is rare earth elements. As I told you, these you can note it down. Rest of the things are very clear. We have discussed them many times that lanthanides are there, 14 elements placed separately below the periodic table's body. Rare earth elements, name is suggestive of itself. They are rarely found in earth crust. They are usually man-made, right? Then actini, the 4 new discoveries, all of them we have covered in earlier classes. It was just put here to make a complete sense or the complete study of the periodic table, that we have learned about the groups, periods, blocks, electronic configuration, and everything. Except for F block, I have purposely left periodic table because I want you to do it. And so that I can be sure that you have covered your chapter 2 also well. Now, these are the certain question answer. I have given the question as well as answers here, so as to save the time. That what are the magic numbers? That 2, 8, 18, 32 are known as magic numbers. Why are they called magic numbers? Because after every 8, 18 or 32 elements, the electronic configuration repeats itself. I think we have done this, or have we not done this? Quickly tell me if we have done it, or do I need to elaborate it on more? I will just quickly do it. I'm not getting any response for you. Lithium, sodium, potassium, rubidium, cesium. I will just write it for lithium, it is 2, 1. Sodium 2, 8, 1. This is 2, 8, 8, 1. Then it is 2, 8, 8, 18, 1. What are you seeing? 8, 8, 18. So they are magic numbers. After them, the same valence shell configuration, that is 1 electron is appearing, right? So this is okay. Now we will be talking about what are the periodic properties. The periodic means that as the nature changes, like right now we are in the, at least in northern India, we are having a rainy or the monsoon season. It will be followed by the winter. Winter will be followed by summer. The cycle goes on. For a certain set of a period, we know that in northern India, November, say October to February will be a winter. March onwards, summer will come. So every 3-4 months, the season changes. There is a periodicity, or more easily, which is universal for all of us, that sun rises, sun sets, moon rises, moon sets. Although, if you ask to the geography teacher, he or she will say sun never rises or sun never sets. Still, we can say that. After every 7 days, Monday comes, like that. So we'll be studying certain trends. this is the final outcome. That is, we will have to learn atomic radius, ionization energy, electron affinity, metallic character, electron affinity, all those things we have to study. What are they and how do they change, right? So this is one type of a classification which is given in certain books, right? Or I have put it here for my convenience so that I do not miss any one of them. It is not necessary that we will be taking up in the same order, but definitely at the end of when we end the chapter, we have to be sure about that we have covered all of them, right? And the reason, again, I prefer to tell you reason every time, that earlier this chapter was in class 10th, and I have to bend myself that as if I am teaching you for the first time, not the second time in class 11, right? Now talking about, first of all, I think we will talk about the electronic configuration, which has to be most familiar one. What is the trend? Now we'll be talking in the terms, the trend in the group as well as in the period. Electronic configuration, that is what you got through above with the exceptions intact. For the benefit of the some students who just a reminder for them, 24 and 29, 24 followed by whatever number, 29 followed by whatever number, they have to be taken care as exceptions, right? Next year when you study in class 12 DNF block elements, you will find configuration of platinum also as an exception. But right now you don't have to deal with that. So electronic configuration, we all of us know the valence shell electron will determine all the properties. Sodium and potassium, both of them resemble in chemical properties because they have one electron each. If I can ask you one question, do you wash your clothes and with your hands? Anybody having experience in washing the clothes with hand? Or to put it simply, what is the difference in touch or effect in your skin of hand of the bathing soap and the soap which is used for washing the clothes? Any idea?
Well, I've done it, but I've not felt any difference.
You haven't felt, okay? Okay, in the era, I also belong to this era that who has it? Yeah, yeah,
Understand the skin, it will be different. Like there'll be like lines on the skin if we touch it for too long, and it'll be dry.
I'm unable to understand, Ananya, what you said. Can you please repeat it?
Mom, I said our skin will feel different like when we keep washing it for too long. It will be like there'll be like lines on the skin, like it will be like wrinkles.
Okay. I got it. But my question was on a slightly different thing. I wanted to talk about sodium and potassium rather than this sense, because when I wash utensils, at times I do not have a maid at home. I have to wash utensils. I have to wash. There are certain, I'll say, good quality clothes we prefer to wash with their hands. And my palm, they develop some sort of a irritation or they become hard sort of a thing, right? With this, what I want to say is that the salts which are used in this question came to me because you have learned about the cleansing action of salts, missile formation. There you might be told what is a soft soap and what is a hard soap. So just the potassium soaps, like if you are that Mysore sandal and the brands like Dove, for cleansing, they use potassium salt. Whereas the detergents, which we put it in the category of detergent, they use sodium salts, right? Both of them, I'm just trying to bring out a simile or similarity between the sodium and potassium as they belong to the same group. Both their salts with the fatty acid show cleansing properties, but one is soft and other one is hard. That's why I said they show similar property, but they do not show identical properties. Hard soap means what if some soap you feel your skin is rough or your face is developing some harshness, that means it is having a sodium salt. Whereas potassium salt, like the chemicals which we use for washing hair, or as I told you, the Dove and the different types of face washes, they use potassium salt, right? You may find it a bit off topic, but it is important for us to understand that the elements, if you know sodium shows cleansing action, that means potassium, rubidium, cesium, francium, all of them are expected to show the cleansing action, somewhere to the higher extent and someone to the lower extent. Most of the time it happens. Instead of not knowing rubidium, not knowing anything about rubidium or cesium, we can say that, okay, they must be showing the cleansing properties, right? Is it clear to everyone? Then talking about the sodium and potassium salt, they will be coming somewhere or the other in the following chapters. Maybe when we talk about equilibrium. Okay. Now, how does the electronic configuration changes in a group? As you can see, I have marked it that this is group 2, beryllium, magnesium, calcium, strontium, barium, and radium. All of them have 2 electrons in the valence shell. I have deliberately not written in terms of 1s2, 2s2, 2p6, else it will be becoming too much of long. So, but in order to make you understand that at every step, one shell or one orbit is being added, and more importantly, they have 2 electrons in the valence shell. That means all elements belonging to the same group have same valence shell electronic configuration in a group, right? Now, if I talk about the period, this is the 3rd period. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. I will appreciate and repeating the names again and again so that you also understand the importance. You have to know the S block and P block groups vertically, and the 2nd and the 3rd period. 1st period, hydrogen, helium. 2nd period, lithium to fluorine at least, and the 3rd period, sodium to chlorine. Again, I will make you understand one more thing. If I have not written argon after chlorine, no issues in that, because they are unreactive. You can include them and you may not include them. As you can see, in all these elements from sodium to chlorine, they are having 3 shells, right? But the number of valence electron is increasing. When we move from left to right in a period, number of valence electron increases. Please remember, whenever we are talking about trends, we talk about usually S and P block elements. We do not consider D block elements because in them, the electron enters into the penultimate orbit, right? Is this trend clear to all of you? So that I can quickly move to the next trend.
Yes, ma'am.
Valence electron, we should not spend much of the time on it. Valence electron, that should be clear. They have 2 electrons. And then valence electrons are increasing, right? This is another way of saying the earlier property. Now, talking about valency, it should not be asked because we are in the era of oxidation state, but still valency of group 1 and group 2 and oxygen and fluorine, whatever you know is fine, right? Most of them you know. Rest we will take up in the chapter of chemical bonding when we do it with the help of 1s2, 2s2. It was a class 10th content, class 10th, for class 10th, it is fine. But when we move to class 11th, we need to talk about the variable valency also, right? It's just a image to tell you, you can be asked about it and you know about them. We'll leave this question. This one is interesting. Can you do this? This type of questions are expected for you.
Mom, is it sodium?
Is it a question or answer to me?
It's an answer.
Okay, correct, Ananya. Because it starts with hydrogen, lithium, sodium, right? And that means it's a third period. It should have been, see, you have to have so much of a practice in periodic table that you need to answer this confidently, right? Now, this is another interesting question. Name the element which has double the electrons as present in the double the electrons in its second shell. I'll add to that. This type of a question, since I'm a member of the CBSE committee who asked for the questions for sample questions from the teachers. This type of a question was there. They gave it a name that who am I? With the help of 1 or 2 clues, you have to identify the element. This one was pretty easy one. I'll give you 1 more minute to think about it and then I'll tell you what is the logic in this.
Mom, is it carbon? 2,4.
Correct. See, the moment I said that in the second shell, we know double the number of electrons in the second shell itself is a big clue. First shell always has 2. So the second shell having the double number, double has to be 4. 2 plus 4 is 6 and 6 is the atomic number of carbon. You need to do a lot of practice on these small questions, right?
Yes, ma'am.
Okay, we will be now talking about the one difficult concepts or beginning of the difficult concepts of the periodic table. What is atomic size? We cannot see atom. And if you remember the definition of orbital from the previous chapter, can somebody apprise me what is the definition of an orbital? Please remember again, it is very important. It is space around nucleus where possibility of finding an electron is maximum. Is maximum or highest. Have you heard about this definition or not? It will take me a while if I open your book. See, if you have, please go to this chapter number 2 again. You will find they have shown it with the dotted cloud sort of a thing. Right? Please remember, we may be drawing orbital like this, like this. They are probability. They are not concrete lines. If we say, or if the scientists were sure that atom is a sphere, then the radius should be determining its size, right? But it is not concrete. So we must remember, we cannot, probability cannot be measured accurately. So we just say that size of atom can only be an approximation, right? And or the distance which it is covering will be giving the shape of orbital. So atomic size has to be determined by atomic radius. That is first thing. The second thing, it cannot be very concrete. Like if somebody asks you, what is your height? What can you do? You can put a inchy tape here and find out your entire length. It's not that easy, right? We just have to understand it, that it is an approximation. Please remember it always. Again, on this concept, JEE last year, when, or year before last, when they have a force shift exams, one of the question was on this. If we say that it is 37 picometers, if I have just put a value for hydrogen, just to give you an example, 36 picometer is just an approximation. It could be 35 when let's say the electron is moving near to the nucleus. If it is moving just far away, it can be 38 also. Is it clear to all of you?
Yes, ma'am.
Yes, ma'am.
So this is the classical definition which you have to keep in your mind, that atomic sizes, again, what is the word used here is, it is visualized. It is not, again, not a road. Visualized as a distance between the center of the nucleus and the outermost shell of an isolated atom. There is a purpose of putting the word isolated. Isolated means it is not attracted towards anyone else. If this is an atom 1, it is its electron. Let's say this is atom 2, and it is this electron. And there is, at center, there is nucleus. This electron will be attracted towards the nucleus. Do you agree or not?
Yes, ma'am.
Okay. So for the we say either it is said as isolated atom, or in some of the books you may find it is written as isolated gaseous atom, because in gaseous state atoms are at the maximum distance from each other. In general, when we talk about atomic radius, we mean to say covalent radius, right? There are 3 types of the radius which we will learn here. One is the covalent radius. Assumingly, this is the molecule of hydrogen, right? This distance is, let's say, r. So the covalent radius will be r by 2. Now, what is a van der Waals radius? There are noble gases which do not combine with anybody else. They themselves do not combine. Many of the things exist as molecules, H2, N2, O2, F2. But noble gases, they exist as a separate atom. I think it makes sense to all of you that they will be existing as separate atoms. If I talk about, let's say, helium or neon or argon, if it is neon, how will you find its atomic radius? You cannot, right? So they always have a van der Waals radius. This is the half of the distance between two nearest neighbors. If I talk about the hydrogen gas, it is one H2 molecule. This is the nearest H2 molecule, right? This distance is R. But what about this distance? The distance between the two non-bonded atoms, this distance. This distance, let's put it as Y. And this Y by 2 is referred as van der Waals radius. So what I said here is that covalent radius is half of the distance between two bonded atoms. And van der Waals radius is half of the distance between two nearest non-bonded atoms. Now looking at this first picture, this one, can you tell me which one will have higher value, ionic radius and or covalent radius? Or van der Waals radius? Okay, since I have not discussed ionic, let's talk about covalent and van der Waals first. Which will have a higher value? You can see and refer to the image of H2 molecule. Let me explain it to you. When the atoms are bonded, that means they are attracted more towards each other, right? So when they are attracted, that means the distance between the two atoms is going to be smaller. But when they are not bonded, if you look at this distance, I believe it seems a bit larger. This distance is a bit larger than this distance. So what we can conclude, or what do we want to conclude here is, for a particular element, van der Waals radius is always larger than covalent radius. Is it clear to all of you?
Yes, ma'am.
Okay. Again, I'm telling you, this concept may not be in your books, but it is important from the competitive perspective. Now, talking about the ionic radius. In ionic radius, we say it is the distance between, I believe, cation and anion. Both of them are clear to you. Just say yes or no.
Yes, ma'am.
Okay, great. It is the distance between outermost electron and nucleus, right? So what we have understood for atomic size till now, that atomic size will be measured and compared in terms of atomic radius. An element can have more than one type of a radius, which can be covalent radius, ionic radius, or van der Waals radius. The covalent radius is half of the distance between two bonded atoms, whereas van der Waals radius is the half of the distance between two nearest non-bonded atoms. Noble gases have only van der Waals radius because they do not combine to form a molecule. Ions that can be cation or anion, they have ionic radii, which is the distance between the outermost electron and the nucleus. The very important fact is that whenever I say atomic size or atomic radius, we largely say, when I'm saying atomic, we mean to say covalent radius. Unless or until specified, we are referring to covalent radius, right? So moving on, we will learn what is the trend. As it is very clear from the atomic or rather electronic configuration, and you can see with the increase or with when we move from one element to the another element, what can I say? I can say the number of shell is increasing by 1, right? So as the number of shell is increasing, atomic size has to increase. Is it pretty obvious or not to all of you? The simplest property which we say that atomic size increases as we go down the group. Now, when we talk about, now this is a graph, I have purposely put it here, taken from your NCERT and rather redrawn from the NCERT. The reason being that as we are moving towards NEP, National Education Property Policy, sorry, they are more into asking the questions which are application based. See, if you are given this sort of a graph and maybe one of the element is missing, or they may be, let's say, after bromine, they do not write the atomic size in picometers, right? Then they say what it can be. Should it be less than 99, more than 99, in between 99 and 133, like that? The options will be given to you in that format, right? So therefore, so that it should not come as a shock to all of you that we haven't seen a graph like that, right? I'm expecting a graph type of a paper of a question in the there in the competitive exam and in the internal assessment of CBSE, they can always be there, right? Now, if we talk about period, can somebody tell me what is the reason the size is decreasing, although electron is being added to the same shell?
Ma'am, what was your question? Can you repeat?
I'm saying, okay, let me use another slide to ask my question. I'm saying, when we talk about group, again, I will take that example of lithium, sodium, potassium, rubidium, cesium. We know it is, this is nucleus, this is 2, 8. If I draw sodium, it will be 2, 8, 1. For potassium, it will be 1, 2, 3, 4. It becomes pretty obvious that with each element, one shell is increasing. So that means size will increase. But when we talk about a period, what happens? The electron is entering into the same shell, but we are saying the size is decreasing. That is the question. Why? If I can draw, see, we have taken the example of sodium, the third period rather, sodium, magnesium, aluminum, phosphorus, sulfur, chlorine, and argon. All these elements have 3 shells, right?
Yes,
Then
ma'am.
how is the size decreasing? I'm saying the size is decreasing, but then how? Understood the question now?
Yes, ma'am.
Okay. Now, should I answer it?
Ma'am, is it because they have the same amount of energy?
No. If it is Ritika, I believe, or Ananya,
Yes,
they
ma'am.
cannot have same amount of energy. Why? Because number of electrons have changed. So they cannot have the same amount of energy. Any other answer? That was a good attempt. Any other answer? Okay, now let me explain it to all of you. That so I will be writing the number of protons and electrons for everyone. For sodium, it is 11, 11. Magnesium, sorry, I wrote 12. Magnesium is 12, 12. Aluminium 13, 13. Silicon 14, 14. Phosphorus 15, 16, 17, 18. Here also they are 15, 16, 17, 18. Right? Now imagine that you have this circle made up of a rubber band, which we put up when we tie our what we call it as we make our braids, or when we put up a band there. This is collapsible to an extent. It can be made to do like this. Now, in this case, what is happening? Number of valence electrons are how many? They are 1, 2, 3, 4, 5, 6, 7, and 8, right? If it is a collapsible thing, if I draw it for silicon, right? So it will be attracted towards the center from 4 points. If I'm drawing it for chlorine, it will be attracted towards the center, the same circle. Imagine or assume that whatever I have drawn is of same radii. It will be attracted towards the center at 7 places. And if I draw similarly for sodium, it will be attracted towards the center only at 1 place, right? So what do you think? Which will shrink in size? Is it sodium or chlorine? Any idea, Ria?
Actually, it's sort of disconnect for me, so I can't really follow completely. So yes, I watched the video and learned better because it's going on.
I'm unable to understand what are you saying, Ria. Can you be a bit louder and repeat it again? Anyone got to anyone else apart from Ria? I think there is certain audio issues. Ananya, what do you think? Which will be more attracted towards the center?
Mom, is it the first one?
Okay. See, if I draw, let me find something. Unfortunately, I don't have a rubber band also. Let me get up to find one. See, this is a, let's say, approximately circular rubber band, right? If I plug in at 1 point, its size will, it's deteriorate. If I squeeze it from 2 sides, or if I squeeze it from 4 sides, if I squeeze it from 4 sides, the size I believe should be much more smaller as compared to if I'm squeezing it from 1 point. Isn't it or not?
Yes, ma'am.
Is it clear to everyone that when I am talking about sodium in a layman's language, I'm saying what we have understood in atomic size, the distance between the valence shell electron and the nucleus. There is only one valence shell electron. So that means the valence shell will be technically attracted towards the center from one side. Its size may reduce slightly. In this case, the silicon case, what will happen? This will be attracted or moved towards the center from 4 points. So that means its size will decrease much more. This will be smaller. In between these two, this will be small, this will be smaller. And if I talk about this, it is being attracted towards the center from 7 points. So it has to be the smallest one. Is it making sense or not?
Yes, ma'am.
Okay. So that is why the size of atom or atomic size decreases in a period, right? That you can write. There are two factors which I just purposely skipped earlier. This is the reason for the increase in size for group. As the number of shells are increasing, when we are moving from top to bottom, the atomic size will increase. Why? Another thing which I have put up here is that the distance between the outermost shell and the nucleus is increasing. This you can see in this picture. The distance between the nucleus and outermost shell. Earlier it was this, now it has become this. As the distance is increasing, attractive force will decrease and the size will increase. Use the word increase, decrease very carefully. Distance is increasing, attraction will decrease and size will increase. Now, what we are doing in case of a period, we are adding the electron in the same shell, right? So again, we have to use another terminology. We say that the nuclear charge increases. Nuclear charge means the positive charge. If you look from sodium to chlorine, it is from +11 to +17, right? Nuclear charge is increasing, therefore the size of the nucleus, size of the atom is decreasing. That there was one way which I told you. Now what they are trying to say another reason can be, or another way of putting the reason is that at the center of sodium there are +11 people. Some part of this will be attracting the one electron. If I take the example of chlorine, +17, they have to attract 7. If I put it in this way, probably it does not make that much sense to you, at least in understanding. So for understanding, we have to, we can use this diagram as I showed you, that the number of electrons are increasing and the size is decreasing. But when you are writing the answer, the language has to be that nuclear charge is increasing. Is it making sense to all of you?
Yes, ma'am.
Okay. Now, talking about, and this is something which I have put it at the end. It can be an important question, which I have already told you, that if you see the data, you will realize that at the end, or the technically what I have written is correct, that the size of argon in this case will be slightly larger than chlorine. There are two reasons for it. For chlorine, you will be finding the value of covalent radii. And for the argon, you will get the value of van der Waals radii. Right? Because it does not form a molecule. So, and van der Waals radii is always larger in size than covalent radii. Again, an important reasoning question, right? the basic reason is written here, and this is the technical reason behind it, that outermost shell is completely filled, so their repulsion is greater. Like if you have a marriage hall of 200 people, and there can be two situations. In one situation, there are only 100 people in it, and another day there are 200 people occupying it. So when there are 200 people occupying it, it becomes difficult to breathe. It is the situation with chlorine. And same, and it becomes more difficult for argon to accumulate the next electron, right? So that is again an important question. Now, talking about the cation in anion, what will be the variation in size of cation and anion? If I have sodium cation, sodium atom and sodium cation, which will be larger in size? This again, we have to compare in terms of proton and electron. Sodium has 11 protons and 11 electrons. It has lost one electron, right? Then it has become sodium cation. There's 11 protons, but only 10 electrons. So which should be smaller in size? Similarly, I will put it for anion. Chlorine accepts an electron to become chloride. It has 17, 17, and it has 17, 18. Okay. We will again make a rough sort of an image as we did it in the earlier section. There are plus 11 people sitting, there are 11 persons sitting at the center. They have to attract 11 other people. In this case, at center, there are 11. Now they have to attract only 10 people. What has happened to the force of attraction? Has it increased or decreased? Quickly answer the question. Any idea, Shweta?
Can you repeat what you asked?
What will happen to the force of attraction? We have 11, which will, it will be greater in sodium or sodium plus.
Ma'am, sodium atom will be like greater, but sodium plus atom like will have like more energy to like to pull the electrons towards the nucleus.
Okay. Ananya, what is your take? Okay. Okay, let's make it as a chocolate story. You have, on your birthday, you want to distribute chocolates. You have got 11 chocolates and you have your 11 friends. Everyone is going to get one chocolate, right? But now in this case, you have 11 chocolate to distribute among 10 friends. Everyone's share has increased, I believe, by a certain fraction, 1 by 10 or 1 by 11th, isn't it? Everyone will get 1 plus something X. Here, everyone was getting only one chocolate. Here was everybody is going to get 1 plus a very small part of it in a larger quantity. Making sense?
Yes, ma'am.
Okay. So that means what I'm trying to say, more attraction and therefore a smaller size, right? So what we can conclude that cation is smaller in size than its corresponding neutral atom. Is it clear? It is important to say corresponding neutral atom. Why? Because I can compare, or I should compare sodium with sodium cation, potassium with potassium cation. We cannot compare sodium with calcium cation. Is it clear?
Yes, ma'am.
Okay. We'll quickly wrap up in next 2 minutes with this chlorine. Now here you can see the cases reverse. They were 17 person at the center, or we had 17 friends and we have to distribute 17 chocolates, right? But what has happened? We got one more guest or one more friend. Now we have 17 chocolates to distribute to 18 persons, right? So what will happen? Everyone's share will decrease by a very small fraction x, right? So that means what? Attraction is decreasing. What you wrote for cation is reverse is true for anion. Lesser attraction, that means everyone has got lesser amount of chocolate. So lesser attraction, that means larger size. Same thing, you have to write that the size of anion will always be larger than the corresponding neutral atom. Is it clear to all of you?
Yes, ma'am.
Okay. Now we will end up the class with one question. This is your homework. Remember, you have two homeworks now, atomic number 62 and 87. You have to write configuration. And for them, you have to find out the largest and the smallest species. Is it clear?
Yes, ma'am.
Okay, so that's, I know we are already late by 10 minutes, but it was important to cover it till this point so that we can complete the topic. And if you have any issues, we will discuss it again. You may feel that cation and anion are taught in a bit jiffy. We can always, if you have any issues, we will discuss or we'll start from that in the next Monday class, right? So thank you for being there. Have a remaining good day and goodbye. Take care.
Thank you, ma'am.
Welcome.
Thank you, ma'am.
Welcome.
Thank you, ma'am.
Welcome.